So in last video, we gave example of predicting test score based on hours studied. Now building the model, we're going to follow what I like to call a core workflow. It's like a step-by-step recipe for prediction that you can use for all sorts of different machine learning problems. Our recipe has 5 main steps. First, we'll prep the data, just separating what we know, the study hours, from what we want to predict, the score. Then we'll split our data, teach the model with one part, ask it to make predictions on the other part, and finally, check its work to see how accurate it was. Let's walk through it. We're going to build a complete machine learning model from scratch. Don't worry if you're a beginner. I'll explain every single line of code in simple terms. By the end of this video, you'll have created a working prediction system that can forecast exam scores based on study hours. So let's get started. Alright, the first thing we need to do is import our Python libraries. Think of libraries as toolboxes. Each one contains pre-built functions that save us from writing everything from scratch. Let me explain what each library does. First, we're importing NumPy. NumPy handles all our mathematical operations and works with numbers efficiently. Next is Pandas. Pandas is like Excel for Python. It helps us organize data into tables called DataFrames. Then we have Matplotlib and Seaborn. These are our visualization tools. They create beautiful graphs and charts. And finally, Scikit-learn. This is our machine learning powerhouse. It contains all the algorithms we need to build prediction models. We're also importing specific functions from Scikit-learn. Train test split will help us divide our data. Linear regression is our main algorithm. And those 3 metrics will help us measure how good our model is. The last line sets the style for our graphs to make them look professional. When we run this cell, we see a success message. Perfect. All our tools are loaded and ready to use. Let's create our data set. We're building a simple example about students. We want to see if there's a relationship between how long students study and their exam scores. Here's how we create data in Python. We're making a dictionary. A dictionary in Python is like a container with labels. The first label is hours. This stores the number of hours each student studied. Notice the square brackets. That's a list. Each number represents one student. So the first student studied 2.5 hours. The second studied 5.1 hours. And so on for 20 students total. The second label is scores. These are the exam scores those students achieved. The first student who studied 2.5 hours scored 21 points. The second student who studied 5.1 hours scored 47 points. We convert this dictionary into a Pandas DataFrame. This makes it look like a proper table with rows and columns. The print statements show us what we created. The first 10 rows appear as a nice table. Then we see statistical summary, things like average study time and average score. Looking at the output, we have 20 students. The average study time is about 5.7 hours and the average score is 56 points. Already, we might suspect that more study leads to better scores. Let's visualize it to be sure. This is one of the most important steps in any data science project, visualization. Before building any model, we must see our data. A picture tells us more than numbers alone. Let's walk through this code. plt creates a new blank canvas for our graph. The fixed size parameter sets how big it will be. 12 inches wide by 7 inches tall. plt.scatter creates a scatter plot. Each student becomes one dot on the graph. The first parameter is the x-axis, that's study hours. The second parameter is the y-axis, that's exam scores. Then we set the color to Dodger blue, that's a nice bright blue color. The letter S sets the size. 200 makes big easy. To see dots, alpha controls transparency. 0.6 means slightly see-through. Edge colors and line width. Add a dark border around each dot for clarity. The title adds a heading to our graph. We make it large with font size 18 and bold with font weight bold. X label and Y label name our axis so people know what they're looking at. Grid adds those helpful background lines. The annotation section adds a little note pointing to the highest score. It shows which student did best. Tight layout makes sure everything fits nicely without overlapping. And plt.show actually displays the graph. Look at this beautiful visualization. See how the dots form an upward trend? As study hours increase along the bottom, exam scores increase going up. This clear pattern tells us there's definitely a relationship here. More study time really does lead to better scores. This is perfect for linear regression.